let's continue our discussion on solutions chemistry. And ngayon naman, pag-uusapan natin ang ionic activity or simply activity. So ano ba to? Sa ionic activity, ito yung tinatawag din natin na effective concentration. Okay? So far kasi, we describe the chemical potential of a certain solution by describing or measuring its concentration. Tama? And we are assuming na yung solution natin is ideal. And pag sinabi natin ideal, isa sa mga characteristic niya ay it's a dilute solution. But what if you have a case for real solutions? No? Real solutions. So for real solutions, you want to describe them, you want to relate the chemical potential not to the concentrations but rather through their activity or ionic activity. So to compute the activity, ang gagawin lang natin is you have to multiply the concentration of that species by what we call the activity coefficient. Okay? So the activity coefficient times the concentration of the particular species. So again, itong ating delta dito, yan yung activity coefficient. Now, of course, if you have a case for ideal solution, ibig sabihin, pwedeng dilute siya. Kasi pag sinabing ideal solution, again, walang interaction between the solutes and even the solvent particles. For ideal solution, yung ating delta or activity coefficient will be equal to 1 such that yung activity is simply equal to the concentration. Again, that is true only for ideal solutions. So the next question here is how do you compute the activity coefficient? Okay? So mayroong mga iba't ibang equation that can compute for this activity coefficient and they arise from the different theories. Okay? And one of these theories is yung tinatawag nating Debye-Hackel limiting law. Okay? So Debye-Hackel limiting law. And just like your Raoult's law, Henry's law, and the ideal gas law, limiting law din si Debye-Hackel. And basically, the equation that arises from this theory will give you the activity coefficient equation. And that will be in the form of, so you'll have log of the coefficient equals minus 0.51, okay, z squared times square root of mu. Now, let's define kung ano tong mga variables and parameters na nakapaloob sa equation ito. So first, we have mu, no? So si mu, yan yung tinatawag nating ionic strength ng solution. So ionic strength. And to compute for the ionic strength, ang magiging equation niya or formula is 1/2 times the summation of concentration of that species or ion multiplied by the charge of that ion squared. Okay? So, since na-define na natin dito yung Z, so alam nyo na kung anong ibig sabihin ng Z dito sa ating Debye-Hackel equation. So, Z is the charge of the species or ion. Okay? So let's try to solve or answer this question. What is the calcium ion activity of a solution containing 0.010 molar in calcium chloride and 0.20 molar in magnesium chloride? So before we solve this problem, let's try to summarize kung ano yung mga given na information. So you have the following ions in the solution. So you have calcium, you also have magnesium, and both compounds will contain the chloride ion. Now, we want to look for the concentration of each of these species. Okay? So, yun yung tinatawag nating CI, C sub I. So, for calcium, ang concentration niya, based on this given na 0.01 molar calcium chloride. So, therefore, ang kay calcium is 0.01 molar din. Okay? Now, for magnesium, mayroon tayong given dito na 0.20 molar of magnesium. So, 0.20 yung ating concentration for the magnesium ion in that solution. Now, for chloride, it's the sum of the concentrations coming from the calcium chloride compound and the magnesium chloride solute. Right? So, that will be 2 times 0.01, this is coming from calcium chloride, plus 2 times 0.20. And this is equal to 0.42. So, bakit times 2? Kasi for each of these compounds, there will be 2 chloride ions na makikita mo sa solution. Okay? Because of the subscript for Cl. And next, we want to determine as well yung charge ng species. So, for ion, for calcium ion, it's positive 2, right? Titignan mo lang yung charge. For magnesium, it's also positive 2. And for chloride, it's minus 1. So, because mayroon na tayo nitong mga information na to, we can already calculate for the ionic strength of the solution. So, that's 1/2 summation of Ci Zi squared. And that will be 1/2. Isa-isay natin yung mga ions. So, let's start with calcium. That's 0.010. And then the charge is positive 2 squared. Next is for magnesium, 0.20 times the charge of positive 2 squared. And lastly, 0.42 for chloride times the charge of minus 1 squared. It doesn't really matter kung positive or negative kasi may square naman yan. So therefore, you will be able to compute for the ionic charge and that will be equal to 0.630. Next is we can determine or compute for the activity coefficient. So we will use the Debye-Hackel limiting law. So log of the activity coefficient is equal to minus 0.51 z squared times the square root of the ionic strength. So that will be minus 0.51 z squared. Let me write lang muna yung general working equation natin because again, the question here is we want to calculate the activity for calcium lang. Okay? Calcium lang ang ating i-compute. So, let me rewrite this equation as log of coefficient of the calcium ion, okay, equals minus 0.51 times the z, no, of the calcium ion squared square root of the ionic strength. So, minus 0.51, z of the calcium ion is 2, positive, no, squared, times the ionic strength is 0.630. So, therefore, you will be able to compute yung coefficient for calcium at mag-i-equal yan sa 0.0240. Alright, so we have now the activity coefficient. So, finally, we will be able to compute for the activity of the calcium ion. So, again, equal siya sa coefficient, activity coefficient of the ion times the concentration of the ion. So, the activity coefficient is 0.0240, gaya na na-compute natin. And the concentration of calcium ion, kukunin nyo yan doon sa table kanina. Right? That's your 0.010. Okay? And therefore, your activity or effective concentration for the calcium ion is 2.4 times 10 raised to negative 4. That is now the final answer.